This is a review for Unit 14. We have three topics that we're going to focus on: solving quadratics with roots, both square roots and cubic roots, finding discriminants, and solving quadratics using the quadratic formula. First up, solving with roots. If we see something like n squared, but there's not an n, we can often treat this like an equation where we get n squared by itself. So we have n squared is equal to 4. Most of these problems are going to be like that, where you add something, then divide something. The goal is to get n squared all by itself. At that point, we take the square root of both sides. So n is equal to plus or minus 2. Because 2 times 2 is 4, and negative 2 times negative 2 is also 4. The reason for this is, if you think about the quadratic, it functions like this, so there will always be two answers on either side of the curve: the positive answer and the negative answer. We write that succinctly as plus or minus 2. To get b squared by itself, first I do minus 8. So I have 9b squared is equal to 180. Then I divide by 9. So b squared is equal to 20. 20 is not a perfect square, but it has perfect square factors. So if I take the square root of both sides, I have b is equal to plus or minus the square root of 20. And I can simplify this to the square root of 4 plus or minus the square root of 4 times the square root of 5, or plus or minus 2 root 5. So we look for, if that's not a perfect square, does it have a perfect square factor? And in this case, that perfect square factor is 4. So we split it into root 4, root 5. The root 4 gets replaced with the whole number. The root 5 stays. This one's similar, but we have to divide. So imagine if I add 8 to both sides. That's my first step. I have 2x squared minus 1 is equal to 16. Then I divide by 2. I have x squared minus 1 is equal to 8. Then I'll add 1. And I have x squared is equal to 9. Nice, a perfect square. So x is equal to plus or minus 3. There's a couple ways I could have handled that. I chose to divide right here at this step. If I distributed, it would end up the same way. So it doesn't really matter. I'd be doing 18 divided by 2 instead of 16 divided by 2 plus 1. Either way, we end up with x squared is equal to 9. When we take the square root, you get plus or minus 3. Minus 16 to both sides. I have negative 2x squared is equal to negative 46. Divide by negative 2. I have x squared is equal to 23. When I take the square root of both sides here, I get x is equal to plus or minus the square root of 23. There are no perfect square factors for this one, so I just leave it like this. And I'm done. Notice that all of these, 1 through 4, had two answers. Either 2 or negative 2. 2 root 5 or negative 2 root 5. 3 or negative 3. Root 23 or negative root 23. This next one I'm going to add 5. And I have x cubed is equal to 100. To do the cubic root in a calculator, you can press the Math 4 button. And all you have to type in is this, and it will either give you an answer or a decimal. If it gives you an answer, you write it down. If it gives you a decimal, then you write it as the cube root of 100. There is not two answers, plus or minus. There's only one. All done here. For this one, I'm going to add 3 to both sides. I get 0 is equal to negative 7y cubed. When I divide by negative 7, I get that 0 is equal to y cubed. If I was to take the cube root of 0, well, that is just 0. Only one answer. And I'm done. So most of this first section is, can you rearrange equations, solving for either the letter squared or the letter cubed? And then do you know how to take the square root and simplify if it's irrational, if possible? Notice that the square root ones have two answers, the cubic root ones have one answer. Next up, discriminant of the quadratic equation. So the discriminant equation is this: b squared minus 4ac. So we have to be able to identify, for an equation like this, what are the values for a, b, and c. And a is 1, b is 2, and c is negative 2. They're the coefficients for the x squared term, the x term, and the constant term. So I plug that in to my calculator, just like this, making sure I use all the parentheses. And there's a 2 here, and a 1 here, and a negative 2 here. Plugging that into the calculator, I get 12. That's my discriminant, and I choose this. Similar thing here. A is 6, B is negative 1, C is 3. I plug them into the formula, b squared minus 4ac. So something squared minus 4 times these values. That's how I type it into my calculator. A negative 1 here, a 6 here, a 3 here. The common mistake that people make is they put that negative outside the parentheses, and then it's wrong. If you do this one correctly, you'll get negative 71. For these, you first have to solve them for 0. So we're going to add 3x squared here and here. And I'm going to subtract x here and here. I'll just do it all in one step. That gives me 5x squared minus 2x plus 63 is equal to 0. So when I plug into my equation, b squared minus 4ac, the values here are negative 2, 5, and 63. It's tempting to look back to the top and use some of the original values, but those are not my a, b, and c. Here you can see that a is 5, b is negative 2, and c is 63. So the answer to this one is negative 1,256. Here, first I want to get this equal to 0, so I'm going to add 5x squared to both sides. I'm going to add 6x to both sides. And I have everything equal to 0, which means I can start the problem. So b is negative 12. Let me write those out. A is 2, b is negative 12, c is negative 21. So negative 12 goes here, 2 goes here, and negative 21 goes there. Plug it straight into your calculator as written. The answer that you get is 312. All right, one last problem here. We're going to add 6x squared to here and here. We're going to add 2x here and here. We have 3x squared minus 16x plus 64 is equal to 0. That means that a is 3, b is negative 16, and c is 64. So if I plug those into b squared minus 4ac, I'm going to plug in a negative 16 here, a 3, and a 64. If I put that into my calculator correctly with parentheses, I get negative 512. So for this entire section, the discriminants, we are using one formula, b squared minus 4ac. It's part of the quadratic formula. Sometimes they're already written in standard form, so a, b, and c are just in order, ready to go. Sometimes I have to solve them for 0 first. We call that putting it in standard form. Then I can plug them into b squared minus 4ac. For the final section, this is the quadratic formula. It's similar to what we started to do with the discriminant, but there's more steps. So what I recommend first is making sure your quadratic is equal to 0, that's step 1. Finding out what a, b, and c are, that's step 2. Evaluate the discriminant, that's step 3. And then plug in and find your answer. And there's 3 different types of answers you will see. So let's go through them and then summarize at the end. Here I'm going to add 4p to both sides. So I have 12p squared minus 5p minus 2 is equal to 0. That means that a is 12, b is negative 5, and c is negative 2. And first, let's find the discriminant. That's going to be negative 5 squared minus 4 times 12 times negative 2. And that's 121. So if I think about the quadratic formula as being negative b plus or minus the square root of 121 divided by 2a, this piece gets plugged in right there. I'm still going to use my original a value and my original b value and replace. So this negative b turns out to be negative 5. And this a value turns out to be 12. So I'll put parentheses around those. And remember that 2 negatives cancels out. So this is going to be 5 plus or minus the square root of 121 all over 24. And if I know what the square root of 121 is, I can try that in my calculator. It turns out to be 11. it simplifies to a whole number. So my first answer is 5 plus 11 divided by 24. Make sure you're doing that with parentheses, or perhaps you can use the fraction trick I showed you, how to do these in the calculator, and you get 16 over 24. Math enter, enter will reduce this to 2/3. Your second answer is going to be 5 minus 11 divided by 24. That's going to give you negative 6 over 24, or negative 1 over 4. So those are your two answers, 2/3 and negative 1/4. First step here is I add 4m squared to both sides. I get m squared plus 2m plus 1 is equal to 0. So a is 1, b is 2, c is 1. Let's plug that into b squared minus 4ac. So that's 2 squared minus 4 times 1 times 1. In this case, you get 0. So if I'm plugging into negative b plus or minus the square root of 0 divided by 2a, this value just gets plugged in there. The square root of 0 is just going to be 0. So does it make sense to add or subtract 0? You're going to get the same result. So it turns out when we have a 0 there, it's just going to be this. My b value was 2, and my a value was 1. So negative 2 divided by 2 is just negative 1. There's only one answer when our discriminant is 0. This one's already in standard form, nice. A is 5, b is 19, c is 17. So I'll start with b squared minus 4ac. That gives me 21. If I use the formula negative b plus or minus the square root of 21 all over 2a, let's replace b now. B is going to be a 19, and a is going to be a 5. And can I simplify the square root of 21? The answer is no. It's not a perfect square. So I can leave this as negative 19 plus or minus root 21 all over 10. And that is my final answer because there is no way to simplify root 21 at all. It's not a perfect square, doesn't have any perfect square factors. So here a is 2, b is negative 7, c is 1. Let's start off by doing b squared minus 4ac. This gives me 41. So I'll do negative b plus or minus the square root of 41 all over 2a. And my b value is negative 7. Notice what happens there. The negatives are going to cancel out. My a value is 2. So this will be 7 plus or minus the square root of 41 all over 4. 41 is another irrational number that cannot be simplified, so I leave it like that. Last problem, if I add 4 to both sides, I get 2k squared minus 8k minus 1 is equal to 0. This means that a is 2, b is negative 8, and c is negative 1. So if I plug into b squared, it's negative 8 squared, minus 4 times a times c, I get 72. So negative b plus or minus the square root of 72 all over 2a. Let's replace b with negative 8. The negatives are going to cancel. Let's replace a with 2. And root 72 has a perfect square factor. So let's simplify this a little bit. This will become 8 plus or minus, and this will become a 4. And let's make this root 36 root 2. Because I look for perfect square factors. And then I simplify. We've been simplifying radicals throughout the year. This is another opportunity to do so. So this becomes 8 plus or minus 6 root 2 root 4. Notice that root 36 got turned into a whole number and the root is now gone. Also notice that 8, 6, and 4 have some common factors. I can divide everything by 2 and simplify this just a little bit. So my final answer is 4 plus or minus 3 root 2 all over 2.